In this video, we're going to talk about completing the square, just in case you might have forgot, because I know that this is one of those things that you could remember a formula, but I really think that if you can see the visual, then if you forget that formula, then you at least have the visual to fall back on. And I actually end up using this, at least visualizing in my head and drawing pictures more often than not. And so I'm going to do two examples. One, in which case the coefficient, your x squared coefficient is 1, and then the second one where it's not, it's 2 in this case. And I made it kind of simple because it's all even, but the principle still stays the same. Okay, so let's just remember what the idea of completing the square is for, and that is to essentially make something factorable. So my end goal at this point is, instead of having the left side in this standard form, and so pretend right now that this is blank, the question mark is what do you have to add in there? What you're trying to do is to make it, rewrite this thing into, you do some math magic and you get to x plus something squared, literally completing the square. So the square part comes from the squared. Okay, so how am I going to get about that? Well, let us draw some pictures. So, and you might have seen the idea of algebra tiles, and if you're tired of this, I apologize, but if you're tired of it, then figure it out some other way. But I'm going to keep explaining it this way. So you have an x squared tile right here. And when I say x squared, I mean x squared is its area. So if this is a square, then the area, and the area is x squared, then that means that the dimensions of this thing have to be x by x. I then have these 10 little x tiles. So each of these is x. And when I say it's x, well, I'm going to make it so that one length is x and then the other one is 1. And then I have 10 of these, so I'm going to fast forward this. Okay, so there's my x squared, there's my 10x, and then I have nothing else. And right now, this is equal to 12. I could draw 12 little individual 1 tiles, but well, let's do that. Okay, 2, 3. Oops. That's a mistake right there. So I have 12 1 tiles on the right side now. Okay, so the idea of completing the square is literally rearranging these tiles into a square. And so I know at some point I'm going to have a square here. And I'm shrinking it to just fit it into this page. But, well, what's going to happen? There is a way to do this. Like, if you had the tiles physically, then you could rearrange them. And I'll drop a link in the description so that you can go there and actually try it out yourself. But what's going to happen is that, well, the x squared can't go anywhere except like in the corner here. So I'm going to put that x squared there. Now, I have to build a square. So that means that whatever this length is, if I call it, I don't know, c, then this length here has to also be c. The only way to arrange these 10x tiles around that then would be to put an equal number of them on both sides. So of those 10x ones, I'm going to put 5 of them here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So right here, inside there's 5x tiles. Inside there's 5x. Oops, 5x. Now our square is not complete, and we knew that because otherwise we would need to complete the square. Because as is, the only way you could factor this is x times x plus 10, and then that would equal to 12. But this would be annoying to solve. So the question is, how much more do I need? So I'll write that in there. How much more, or how many more? Much? Let's say how much. More. Well, let's think about this. When I throw these 5x tiles in on either side, what are the dimensions now? Well, we have on here, right here, this is x by x. We already know that part. Since, I'm going to zoom in here. On this here in the bottom, I'm going to look at the bottom right corner here. The height of each of these long rectangles is x. And if each of the side pieces is 1, right there, then there's 5 of them, so this has to be 5. And likewise, on the other side, this would have to be 5 by x right here. So what we are looking at inside here is a square with dimensions 5 by 5. And so that would be 5 times 5. So I need to add in there 25. So that's what I'm going to do, is I'm going to add in a plus 25. Now this is still an equation that we're working with. And so if I add 25 to that left side, then you know I also have to do it to the right side. So I'm going to add in 25 here as well. Some people do it this way, and they add 25 and then also subtract 25 on the same side. That would work just as well. This is just how I explain it, because eventually I'm going to want to factor this thing anyway and get it by itself. So when I add in 25, that is what's going inside this question mark right here. So let's write the new result here. This then leads us to say that I have x squared plus 10x plus 25 equals now 37. Now I'm going to actually write this 25 in green so I know that it was the new thing. Okay, and I'm also going to draw my square here again, but I am going to abbreviate the square a little bit to help us factor it, just so we can see why this works. So in the bottom left here, there was x squared. In the top right, there was 5x. Top left. And in the bottom right, there was also the 5x. And in the 25, that was the new 25 there. Remember, my goal was to factor this thing into a perfect square. And the reason we did that, or we know it's going to be possible, because we purposely made it a square over here. So, oopsies. Let's just leave that there. Yuck. Okay, so now let's factor this. Well, let's see. We already factored it before, but if you factor this by pulling out the dimensions, it's going to be x plus 5 by x plus 5. And so you know that this factors into x plus 5 squared equals 37. And that would be your final answer. Well, I mean, depends on what the problem is actually asking you to do, but that'll be your final answer. So if you actually want to solve it, say, solve for x, then you could take the square root of both sides. X plus 5 equals the positive and negative square root of 37. And so x would equal negative 5 plus or minus the square root of 37. And those would be your two answers. Okay, but what if your x squared coefficient is not 1? In this case, it's 2. So my suggestion is pretty much always going to be this, is to make it 1. And there's two ways you can think about it. Some people like to think of it as, well, you could divide everything by 2, so we could do that. And so I'll be left with, in this case, x squared plus 8x equals 15. And then you're still trying to figure out what goes in here again. Another way people like to think of it is if they factored out the 2. So instead, we're going to go to this, and we end up with 2x squared plus 8x plus something that equals, and on the right side, you don't actually have to factor out if you don't want to, and that's totally fine. And so now what you're going to do is just look at what you have inside here. So on the right side, on the left side option number 1, I'll say, and there's option number 2. And option number 1, or method number 1, you can just complete the square just like we had been. And so I'll quickly draw the picture here. If I have an x squared, that would have to go, so here's my box. So my x squared is going to be in the corner there. If I have 8 x's, I know I'm going to have to split them in half to get an equal length on either side of my square. And so this is going to have to be 4x and 4x. Notice here, at this point, you already know what your factored form is going to be. It's going to be x plus 4 squared, because x plus 4 by x plus 4. The amount of space I'm missing then is I'm going to have to add in 4 times 4, or 16. And so I'm going to add 16 to both sides. That'll leave us with x plus, you can sometimes skip this step, but for this video, I'll just write it in just in case. X squared plus 8x plus 16 equals 31. And so you have x plus 4 squared equals 31. That's totally fine. Another way, let's take a look at the method number 2. If I do the same process, let's take a look. So I have 2, let's just look inside the parentheses like I said. Notice that process is going to be exactly the same. You're going to have to draw in x squared, 4x, 4x, and add in the 16. Now think about this though. If we look at the left side of the equation, so I'm going to split this down the middle here. If you look at the left side of the equation, how much did you actually add? Well, notice here, we only added the 16 inside the parentheses. And so if I work it out, if I multiplied that 2 back in, how much did you actually add? Well, since you have 2 parentheses and inside each parentheses you added 16, you actually added 2 16s or 32. And so you need to account for that by adding in 2 times 16 on this right side, plus 2 times 16. That's really the only thing that changes. A way that you could get around this would be to, well, actually, let's just leave it at that. So that's just the thing you need to be careful of. So the one thing I like about dividing by 2 on this first method is that it eliminates that confusion because you don't have to deal with that anymore. So hopefully this, well, actually, let's finish this up now. So I'm going to add that to 30, add 32 to both sides. So what do I have? I have 2. Now I'm just working with the parentheses here. So we know that that parentheses now has been made factorable. X plus 4 squared equals, let's see, 30 plus 32, which would be 62. But notice here, if I divide both sides by 2 anyway, I'll get back to this. And so no matter how you look at it, it should be possible. Again, my preferred way would be when the x coefficient is, when the x squared coefficient is not 1, I would usually go this way pretty much 90% of the time. But do what works for you. Do the way that makes sense to you. Another way to visualize this way, actually, number 2, is that think of whatever the x squared coefficient is telling you how many squares you're making. And so in this case, you have 2x squared plus 16x. Actually, let me pull up and let me clear out this off. Okay, so one way that I was trying to explain it was if you put your 2x squareds, but you're making 2 separate squares. So you're building a square around there. So you have 16x's. If you're gonna split them between 2 different squares, you gotta put 8 of them over here. And you have to put 8 of them over there. And of those 8, you know that you're gonna have to split them up evenly. So here are gonna be 4 of the x's. There's 4 of the x's. Here's 4, and here's 4. And so now, how much do you have to add in? Well, to this square, you have to add in 16, 4 times 4. And over here, you have to add in 16. Remember, this is all just the left side of this equation right here. And so if I'm gonna have to, it still has to equal 30. And so how much did you actually add? You have to add in 16 and then 16 again. So that's another way to visualize it.